for doing a quick sort, let's say you have given with some numbers, let's say 70, 60, 40, okay, 100, let's say 100, 90, and 50. And I want to sort these numbers using quick sort. So what quick sort says, quick sort has a concept, has a concept of deciding a pivot element. What a pivot element? Let's say pivot is nothing, a number, a number that you can choose from this array, any of these numbers. Okay. So if we'll be trying to, we'll be implementing our algorithm, we'll be deciding how we are going to choose our pivot. So let's say pivot is just a number from this array. Nothing more than that. It pivot can be 70, 60, 100, 90, 50. It can be anything. It depends upon you. Okay. Let's say here what I'm doing, I'm going to choose pivot as 50. So what the quick sort says, if you're choosing pivot as 50, so move 50 to at its right position, because right position means that all the elements that is lesser than 50 should come at the left of this 50, and all the elements that are greater than this uh, 50, it should pivot, it should go on the right side of that. Okay, so I'll take 50. What I'll be doing, okay, so I'll take 50 from here, because 50, 70 is greater than 50. So all the, so what I'll be doing, if any elements in this array is smaller than 50, I'll be swapping the element with that 50. Okay, so let's say 70 is smaller than 50, no. 60, no. 100, no. 90, no. So what I'll be doing, because the 50 will come at the first, because no element in this array is smaller than 50. Okay, let's say if I would have chosen, after that 70, 60, 100 and 90 will come as it is. All these values are greater than 50. So right now we can say that 50 is at right position, 70, 60, 100, 90. Now what I can say, I can choose the 90 again as pivot, or I can choose 100, 60, 70. Let's say I'm choosing 90 again as pivot. So right now what I can say, that 50 is at its correct position. So what I can say, that the elements at the left side of the 50 is already sorted. It means, sorry, the 50 is already sorted. So you have to sort this array, although in this case it is null, and you have to sort this array again. Okay. So for this array it is null, so we are not going to do anything in this part. So again we are going to apply the quick sort. 90 we are going to apply, take 90 as pivot. So in this case I'll be doing 90. I'll be placing 90 at its correct position, and the elements that is great smaller than 90 will come at the left side of 90, and the element that is greater than 90, it will come on the right side of the 90. Okay, 50 will be as it is, because 70 is smaller than 90, so 70 will be as it is. 60 is smaller than 90, 60 will be as it is. 100 is smaller than 90, no. 90, okay, we have came to this position. So now 90 will come here first, then 100 will move there. Okay, now we can see that 90 is at correct position. Okay, now we have to sort this array, and we have to sort this array. Okay, so again in this case I'll be choosing a pivot element again. Let's say I'm choosing 60 right now. So 60 will come, 50 will be as it is. 60 will come on its own position. Its correct position will be here, because 70 is greater than 60. 70 will come here, and 90 and 100, because if there is only single element, and if you want to sort the single element, it will be already sorted, so you don't need to do anything. So we can see that yes, we got the sorted array. In the initial it was not sorted, but we got the sorted array. So as we can see that what we are doing, we are repeating some concepts again and again. Okay, because what we are doing for this complete array, we are doing for this smaller array and this smaller array, and for what we are doing for this bigger array, we are doing the same concept for this array and this array. So it means that we are dividing our main problem into sub problems, and our function is solving that sub problem again. Okay, is it fine? The concept of quick sort, or do anybody is having any problem with the concept? If it is clear, then we can move to the then we can move to the okay. So Pandu is asking how to choose the pivot. As I have already told you that there is no restrictions that how you have to choose the pivot element, but it depends upon the situation that how we are going to get the input. It totally depends upon that situation that how you are going to choose the pivot. Right now in this example, what I have did, I have chosen the pivot as the last element. You can choose the pivot as the first element. You can choose the pivot as the middle element. You can choose the pivot as the random with the random function as well. There is no restriction of that. Okay. So pivot is just number. So what you have to take, let's say if you are writing the algorithm, you should be clear that that which index you are going to take as the pivot. Let's in the example I'll be taking the last element as the pivot. Oh, no, there is any best way of choosing pivot. Pandey has already have said that it depends upon the situation. It depends upon the input. Most of the time we write the code quick sort as it is. Let's say you are solving some problem on any online contest. So you notice something that the input that are coming, that is in specific, in some specific order, but it is not sorted. In that case you can check this, you can write some inputs and you can see that yes, which one element is coming, in which order the elements are coming. So in that case you can choose that if I choose this as the pivot, so my algorithm will perform in well manner, in the efficient way. So it totally depends upon that situation. You cannot try. Okay. So let's come to the coding part. Let's try to discuss how we can write the algorithm for quick sort. Okay. Okay. Let me see. Let me open another ID for it. Just 1 minute. There is no dashboard. Okay. Aryan, will choosing the pivot affects the time complexity? Yes, Aryan, it affects. Sometimes that in the worst case you'll be getting n square in the quick sort, but in sometimes you'll be getting n log n in the case. Okay, so you're saying that when choosing the pivot affects the time complexity. Yes, Aryan, of course it affects the time complexity. But we cannot say that if we are choosing the pivot as this, we'll be getting this best complexity. It depends upon the situation. That's why with the quick sort, you have to choose the pivot by your own. It depends. It totally depends. Okay. So let's say either we can take the input from the user again. Let's say C in and or let's take right. Okay, let's take vector again. We know that it's not it like insertion sort. No, it's something like insertion sort, because in the insertion sort you first find an you have to let's say you have chosen something and you are trying to do it in this. You are trying to place that element at its position, but in the insertion sort we don't know that the elements that is going to come on its left side is going to be lesser than that, and the elements that are going to come after this it will be greater than that. So the foundation is not there in the insertion sort. Okay, and in the quick sort you have to be you have to write that the elements uh, by the left side of that pivot it should be lesser than, and by the right side of it should be greater than that. Okay, so int take input from the user again, int is equal to 0 as b dot pushback. Let's create a print function that should print our vector so that we can know that we have created the that we have created right or not. Let's say print. If I'm passing my vector to it, I should be writing vector int b. So for int I, I'm just printing my vector from this print function. So I think it is already clear with you that I'm using the size function to get the size of my vector, and I just out of I. I'm changing the line here. Okay. So if I'll be passing my vector to my print function, I'll be just printing my element. Let's say if I'm passing 5 elements, say 18, 16, 12, 11, 13. Okay. I should be just, okay, this is 6 elements, 2, 2, 4, 5. I should be printing, okay, I've not included the print slash, so it will not allow vector. Okay, we are getting the output. It means that yes, I think up to here it is already clear because it is very simple code. So let's try to do quick sort. Let's create a quick sort function. Quick sort function. What I was talking about in the quick sort function, I'll be passing my vector as b, and I'll passing my start index. Let's say starting is 0 and end will be n minus 1, of course, nothing else. Okay. So now what I'm going to say, if you have sorted my print, print the vector again. Okay. Let's say what I'm going to do now, I'm going to design my quick sort function. Okay. So my quick, it is not going to return anything. So what I'll be doing, the quick sort as its return type would be void. Okay. Quick sort and vector int of b, int star, int end. Okay. As we all know that if I'm passing my vector through it, vector is by default pass by value, not pass by reference. But if you are using our array is by default the pass by reference. So what I'll be doing, I'll be making it pass by reference by adding an ampersand. Okay. As we have discussed this in the case of binary search, that if my start is going to be greater than end, it means that we have already completed our task. We don't need to do anything. So what I'll be writing, if end is greater than start. If end is greater than start, in that case also, in that case only you need to do. If end is equal to start, it means that there is only one element in the array, and you in that case also you don't need to do anything. You just return from this function, and its return type is void, so you don't need to return as well. Okay. So what I'm saying, that if end is greater than start, in that case only you have to perform the operation or end. After that you don't need to do anything. So what I'm saying, because we have discussed the concept that it is saying that you take a pivot element and place the pivot at its position, and at its left side place all the values that is lesser than that element, and on its right side place all the values that is greater than the pivot element. So what I'll be doing, let's say I'm going to create another function that is going to tell me the pivot, the index of that pivot, because if I've chosen some pivot, it is going to be at some position, and if that partition, let's say the name of that function is partition function. We generally do name it the partition function. So if sorry, let's say pi, that is pivot, if my partition function, if I'm passing my v to it, I'm passing start as well as end. So what it is going to do, my partition function, it is going to choose a pivot from my function, from my data and elements, and it is going to place that pivot element at its correct position, and all the elements that is smaller than that, it is going to make it its left side, and all the elements that is greater than it, it is going to do it's on its right side. So for doing that, and it will be returning the position of that pivot element, that actual position of that pivot element into from this partition function. So into NPI, I'll be getting the index of that pivot element, that actual index of that pivot element. So if I got the pivot is placed on its right position, so I'll be calling my quick sort again. It means that pivot is on its correct position. So what do I need to sort? I need to sort from start to pivot minus one and pivot plus one to end. Okay. So int v, sorry, v start to pivot minus one. I hope you're getting why I'm writing pivot minus one, as well as because pivot is on the correct position. So v pivot plus one as well and up to end. So you need to call the function quicksort function again. Okay. So what I need to do now, I just need to create this partition function. How my partition function is going to be? Its return type would be int, of course, because we know that it is going to return the index of that pivot element. So let's say int partition. I'll be passing my vector through it. Int v. Again, it will be the pass by reference because we are going to change something in that vector, and it should be visible into the quicksort. Okay. Int start, int end. Okay. So what I'm saying, as we have already discussed in the example, that we are going to take the pivot as the last element. Let's say you can take it first, you can take the middle element as well. Let's say I'm going to take it as the last element. So integer pi equal to, let's say the pi is equal to, let's say the value will be equal to vector of that end. Pi will have the value. Let's say it is p. We will have the value that of that pivot value. Now what I'm going to do, I'm going to run a for loop, and I'm going to check that all these values that is smaller than that is smaller than that element. Let's say the smaller element is, if this element that is smaller than this pivot element, I'm going to shift it into its right left place. So because for doing that, I'm going to take, let's say int I is equal to start, because I'll be placing all the values that is smaller than that pivot from the start. I'll be placing that value from the start. Let's say, let me explain it why I'm writing at start. Let's say you have n vector given with us, and you have take, let's say 7, 5, 6, 9, and 3 is given with us. Okay. So now what I'm going to do, okay, not 3, let's say it is 8. Okay. So let's say this is our pivot element, that is 8, because I've already taken that in the P, it will be 8. So let's say start is going to be here and end is going to be from here. What I'm saying that if my 8, if that element that is, I'll be running a loop from 7 to 9, the start, from start to end minus 1, I'll be checking that if 7 is lesser than that 8. If it is lesser than 8, so what I'm doing, I'm saying that int I is equal to start. If it is lesser than that, you swap the value with index I. So 7 is smaller than 8. So 7, the start index and the I index, it is same. So it is not going to affect anything if I'm going to swap. So 7 will be as it is. So, so I'll be increasing my I to I plus plus. So now I is I plus plus. That is I is now 1. Okay. Just see it very carefully why I is 1, because I have swapped that 7 with 7 itself and I have incremented I. Now 5 comes, 5 is lesser than 8. Yes, of course. So it will swap the value with, swap this value with I plus 1. Sorry, I is equal to 1. So 5 will be swapped with 1. Again, the 5 will come here and I will be incremented. I is now 2. Okay. So RN is saying that please repeat the concept by I plus plus. Okay, RN. Let's start it from the, let's start it again. Let's say you have chosen this as the pivot element. Okay. Let's say instead of 6, it is 9 and 6 here. Okay. Then we'll, okay. I think now I'm audible, because I think there was some, again, there was some internet issue. So let's quickly draw it again. Sorry. So what I'm talking about, let's start it from the beginning itself. So what was the, this case, I think it was 7, 5, 9, 6, and 8. Yes. Let's say I have to in the partition function I got this. Okay. So what I have to do, I have to take a I have to take a pivot element, and what I have to do, that pivot element should be at its actual position, and all the elements that is lesser than that pivot element should be smaller than that, and all the elements that is greater than that, it should come on the right side of that. Okay. So for doing that, I'm taking the pivot at the last element. So in the P, 8 will come. Okay. And right now our start is this, and our end is this. Okay. So now what I'm saying, create I is equal to start. Okay. So what I'm saying, that if run a loop from 7 to 6, that is start is equal to n minus 1, and what you need to do, you just compare that P with this I. Let's say the current running loop. Now let's say it is J, because we have already declared I. So right now it is J. J is going from start to n minus 1, and I'm saying that if b of j is equal to, sorry, if b of j is less than p, so I'm saying if it is less than p, so 7 is less than p, of course. So swap both values 7 with index with b of I. So b of I is now 7, and start is also 7. So I'm going to 7 and 7 will be swapped. So it will be 7 itself. Now what I'm saying, increment I by 1. Now I is pointing to this element. Again, j will also come to this. Now it will say that b of j, b of j is less than 8. Yes, it is of course less than 8. So I'm going to say that swap b of j with b of I. B of j and b of I is the same. So it will 5. It will be 5. Again, I comes to I plus plus. That I is now pointing to this. Now j comes to this again. Now I'm saying that p is less that b of j is less than 8. Right now it is not less than 8. So I'm not going to do anything. Again, j is going to be incremented. J is going to become here. Okay. J is going to come here. Now I'm saying that is v of j is less than p. Yes, it is less than p. So again, I'm saying swap these two values, v of I and v of j. Now 6 will come here and 9 will come here. Okay, the loop has ended. If the loop has ended and I is right now pointing to this element, now I'm going to say that swap the values of I and the pivot. Swap the value of I and the pivot. So 8 will come here, 7, 6, and 8 come here. and 9 comes here. Right now I is pointing to this element. So yes, now, right now we can say that 8 is at its correct position and 756 is lesser than this 8 and 9 is greater than this 8. So I should be returning 9 I, and we have performed the partition. All the elements that is lesser than that 8, it is coming to be left side, and all the elements that is greater than that 8, it is coming on the right side. Okay, let's try to code it out. Then we'll get, if you are facing any problem, we'll try to resolve that. Okay, is it clear now? Can we move to the code? Okay, so if what I was saying, that if we have taken I is equal to start, so int j is equal to start, and j will go up to end minus 1. If it is less than end, it is good, it is going to be end minus 1. Okay, now what I'm saying, if that value, let's say that is, if p of j is less than the p, then what I need to swap? I need to swap b of I as well as b of j. I should be incrementing j plus plus. I can either I can write it here, or I can write it here. If it is sorry, I should be incrementing I, not j. Or either I can write I plus plus here, or we can write it here. Okay. So all the elements that is lesser than that, it is going to come here, and now I need to swap. The I will be at the main position, that at the pivot's position. So I'm going to swap the v of I again with whom? With the p of end, because end is our pivot. Okay, so I'm going to swap it, and I'm going to return I, because I know the correct position of my pivot is I. Okay, let's try to run it. Let's see whether we are getting the output correct or not. We have called, oh, we have called our print function. Okay, fine. 11, 12, 16, 18, and 19. It means we are getting in sorted array. Okay, I'm showing the partition function again. Let's say it is, instead of 5, it is 15. Let's try to add 16, 17, 2, 3, 6, 4, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This 14 elements, let's say add 11. Let's see whether we are getting the output correct or not. It should be in sorted array. Okay, 2, 3, 4, 4, 6, 8, 9, 11, 11, 12, 16, 16, 17, 18, and 19. So 16, 16, 16. Okay, fine. It means we are getting the correct output. So anybody is having any problem in this partition function? I think so. Quick sort function is nothing. We are just dividing our main problem into the sub problem, and partition function is doing something for us. Is it clear now? The quick sort. Or do anybody is having any problem in the quick sort? I'm waiting for last swap function, line number 23. Okay, last swap function was something because Aryan, you are asking last swap function. Let's say in here the pivot was 8. So what I was doing, all the elements that is smaller than that. So 8 has come here. Let's say it has come here, and right now I is pointing to this, and because this the pivot value is not at its correct position, so I should be because I is the position, because before I all the values are less than this pivot element, so I should be that value, I should be that index of that pivot element. So what I'm doing, I'm just swapping that p of I with the p of n. P of n is this 8, so I'm swapping it with 8, so 8 is coming on its correct position, and 9 is going to be there. Okay, because what we have did with this for loop, moving 9 to pivot's position. Moving knight to pivot's position, I think you can say it in a better way that moving pivot at its correct position. The pivot was 8 and I'm moving the pivot at its correct position because if all the elements that is smaller than that pivot element is lying here, then pivot should be here. And if I know the index of that pivot element, the actual index that it should be, if I know that that index, I should be swapping it with that pivot element or not. I'm swapping it and I'm returning this index that this is the pivot index of this complete node, and I'm returning the index. Okay. Is it fine for everyone?